Okay, now continuing this. So knowing that we have these factors brings us to our analysis for the domain. What makes each factor become zero? So we'll have 6 over 5 for 5x minus 6. Let's mark it there. Negative 6 for x plus 6 and positive 3 for x minus 2. But do take note that x minus 3 is squared. And 5x minus 6, x plus 6. Now, because this x minus 3 is squared, that means it's always positive, whatever value we use. Then 5x minus 6 is going to be 0 at 6 over 5, so that leaves this behavior. X plus 6 will be negative here and positive for the rest. We're after the sign that says greater than or equal to 0. So of course, we'll be looking into the quotients. This gives us positive, negative, positive, and positive. There. Now, what do you think will be our domain? So solution-wise, we need all values less than negative 6 to use a bracket or parenthesis. Negative 6 is in the numerator, so it's okay if it becomes 0, and we can make use of the bracket because it's an or equal to situation. Together with, this is everything beyond 6 over 5 or more than 6 over 5. And 6 over 5 can be used. Now, is it everything more than 6 over 5? We have to stop at 3 first. The 3 will make our denominator 0, which is always a restriction. And then we can proceed. This is the domain of h of f of x. Now, let's go back to our presentation here. So continuing, again, that's how we determine the domain of h of f of x. And because our domains are restricted for rational functions, range is restricted as well. We cannot have a value for a the domain, that means we will not have a value, maybe a set of values for the range. So for the range, it is uh, determined by what we call the horizontal or oblique asymptotes. And we get those by following this. So we have vertical asymptote. These are determined by x values that make the denominator 0. Horizontal asymptotes and oblique asymptotes is the restriction for the range. Just remember these conditions. So we'll make it simpler. I won't dive into the details as to why. So we consider the degrees of both numerator and denominator for us to find out the horizontal or oblique asymptotes. Here are some examples. So this is the graph of the irrational function 1 over x. This one will have a vertical asymptote right there. When x is 0, horizontal asymptote of y is 0. Why is it a horizontal asymptote? Because we have the numerator less degree compared to the denominator. Let's apply it here. 2x plus 5 over x minus 1 is the function. Of course, the domain tells us that we cannot have 1. So that means we have a vertical asymptote when x equals 1. Now, for the same function, our range is determined first by the comparison of the degrees. We have 2x plus 5 over x minus 1. Same degree for both numerator and denominator, so we can have 2 divided by 1. The quotient of the leading coefficients of the numerator and denominator gives us the horizontal asymptote when y equals 2. And that's going to be the restriction for the range. The range will be composed of all numbers except 2. So let's put that here in the graph. Now you see there the horizontal and vertical asymptotes together. So for us to get more points, let's take up some more values. So we have values to consider, the negative and the positive. So let's use them. You can think of any values that you want, as long, of course, as long as it's in the domain of the function. So here's the points plotted, starting with -8 and the value of that y at -5, the value of the y for it, so on and so forth. You will somehow see how the graph turns out. By connecting those points, we have our graph for 2x plus 5 over x minus 1. Last example, I guess. This one is x plus 4. In the domain, so our domain will be composed of all the numbers except -4. Same idea. But this one, the degree of the numerator is more than the denominator. So that means we cannot just divide their leading coefficients. In this case now, we'll have to prepare to find what the oblique asymptote is.